problems with this. Okay, a sports scientist is testing the relationship between the speed of muscle movement and the force produced. In 10 tests, the following data is collected. Explain why it might not be appropriate to use the Pearson's moment correlation and coefficient. It would not be appropriate to use Pearson's coefficient here because this relation is not linear. That's all you have to say. We cannot use Pearson's because this is not linear. Okay. We then need to calculate Spearman's rank correlation coefficient for this data. So taking a quick look at our data, we can see that A starts here and we go all the way to J. And there's a few weird data points here. We've got this K over here that's in the negative for velocity, and L over here that's in the negative for force. They also don't really fit the pattern at all. They're very clearly outliers, and that's the one thing that I want you to make sure that you remember is eliminate outliers first. So in order to do Spearman's, we have to eliminate the outliers first and don't include them in our ranking, or else that your data is going to be incorrect. The outliers affect greatly how much correlated the data is. So we're not going to include K and L, which notice that they listed those data points here at the end on purpose because those are the two outliers. So instead, we're going to just rank A through J. I'm going to make a teeny tiny little table for myself. And we've got our X and our Y values. For the most part, the X values do all go up in ascending order, right? So the biggest number is going to be 317, so that's going to be 1. 293 would be 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So X kind of goes nicely. Notice that there's a little bit of a hiccup with the Y values, which means that we go down with H but back up with I and then J. So there's going to be a little bit of the rank order being slightly different down here. And so just keep that in mind. So the biggest number is going to be 30.4. Notice that we've got 13.4 repeated here. So that would take up the 5 and the 6th place. So we need to do 5 plus 6 and find the average of the two. Since we're adding two numbers, we divide by 2, which means we get 5.5. So when numbers repeat, in order to rank, you have to average their place or their rank. So 3.4, 3.4, sorry, 13.4, 13.4. And that's 5, 6. So we continue with 7. 10.2, 10.8 would go first, so that's going to be 8 for I. Still 10.3 is above 10.2, so that's going to be 9. And then 10 is actually saved for H. So that's the little hiccup that's going here at the end with our Y values. So this is the first thing that you need to do. Well, first you need to eliminate outliers, and then second you need to rank all of your data. If there's a number that repeats, make sure to average out the two places that those repeating numbers would be taking up. And then all we have to do is insert this data into our calculator. I'm going to go ahead and delete all the things that I've got going on here. All right, and then I'm going to find my stat calculations. A for here. E for here, place it into C, and then I'm going to find my R. R is equal to negative 0.9604. It just says to calculate the coefficient, and so that's all we've done. Oh, make sure to put an S down there at the bottom because this is Spearman's and not Pearson's. Interpret the value of R sub S and comment on its validity. This number means that it is a strong negative correlation, and it's nonlinear. Of which we can say, yeah, eliminating the outliers definitely shows that this is a strong negative nonlinear because it's exponential correlation. And that's all that we're doing here. So Spearman's is for nonlinear. Okay. We're talking about a math test marked out of 80 and an English test marked out of 100 and results that were given. We need to calculate Pearson's product coefficient correlation. There's moment in there as well. PMCC stands for the Pearson number. So it's really just asking for R. I would like for you to go ahead and calculate that on your own. You should have gotten that R equals 0.670. This result means a moderate positive correlation. Moderate because it's still closer to the 0.5 than it is to like the 0.8s and 0.9s. So that's why I would say it's moderate to strong positive correlation. Now I would like for you to take that data and plot it on a scatter plot. When looking at this scatter plot, you should have noticed that it is an exponential equation again. This time, though, we are talking about it going up like this. So your sketch of a real quick sketch of the behavior of the scatter plot should look like this. It's not linear, probably more exponential. Exponential tends to be the most common application type of graph that we see because it's a very applicable model that we see a lot in the real world. Since this is not linear, we cannot use the result that we got from Pearson's, and so now we need to calculate the Spearman's rank correlation coefficient and then comment on what we found. I'm going to go ahead and rank my math scores. Sorry, you don't have a lot of space. And then rank my English scores. '79 and 79 are the two largest numbers that are in the maths slot. Since they share the first and the second rank, we have to average 1 and 2 out, and that means that we have 1.5 for both of those. And then, since that was 1 and 2, 78 and 78 then tie for third and fourth place. So that would then be an average of 3.5 for both of those. Then we continue on with pretty clear data. 74, since this is 1, 2, 3, 4, this would be 5, 6, 7, 8, 9, 10, 11. I put too many slots in. Okay, biggest numbers here, 89. Be careful, 54, then 52, then 49, then 44. Oh. I just jumped a little bit. I need to be careful too. Oh, okay. Sorry, guys. One, two, three, four, five. 44 and 44. Repeat. I did not see that till the very end. So we've got 54 and then 52, which is 6. And then 49. And then 47. And then 44 share 9 and 10. So then this guy and this guy share the 9th and 10th place, which means I need to find the average of those two, which is 9.5. And then 42 is definitely the smallest, so that would be an 11 there. Oh, I'm so sorry for the confusion, but obviously it's not super easy to rank numbers sometimes, and there's lots of room for mistakes, so just be very careful with that. All right, now that you have this data, I would like for you to find your Spearman's rank correlation coefficient. You should have gotten 0.8833, which indicates a strong, positive, non-linear correlation. This is definitely a stronger correlation than what you were getting for Pearson's. And that's true because the scatter plot that you saw on your diagram should definitely have shown you that it was a very strong exponential correlation and just not a very strong linear correlation. All right. State which is the more valid measure of correlation and give a reason. You should say Spearman's. And then you should say something about that it's not linear. Since the data points are not linear, you can't use Pearson's, something like that. All right, guys. Thanks for sticking it out. I'm sorry I was a little scatterbrained today, but hopefully it makes sense. And if not, I'll see you in class and we'll talk about it.